think most of the audience today have been through the paradigm shift from a traditional mobile phone to current smartphones. Thomas, our audience wants to know, what real-world problems does virtualization solve for your customers? And how does the technology actually work?
Thanks, John, for the stage. And yes, it's quite tricky to explain what are the benefits or what do our customers see. This is why I simply took 3 use cases. And the first one is a CNC machine. And CNC machines are really impressive because everything is so fast. So there's if you look at those 5-axis CNC machines, they work extremely accurate and extremely fast. This needs extremely fast, hard real-time control. And many years back, you could only achieve this by having one computing device only acting for the controller functions to control the drives. And the user interface was provided by a separate computer attached to the same network. And so by combining both systems into one, they could really achieve a next step in performance, even increasing the cycle times, making the machine more faster, more accurate. At the same time, having everything on one device saves a lot of money, because if you think about machinery, you need ruggedized devices, a ruggedized controller, a ruggedized UI terminal. So by combining this into one computer using a hypervisor, it really saves a lot of money. You only need one device. It increases reliability because it's one device less. And it also helps with maintenance, installation, and everything else. The control function running on a real-time OS, this is usually extremely stable. There's not much changes or no changes on the OS, and also the controller, usually nobody wants to touch it. On the user interface part, however, there are from time to time updates regarding user interface, regarding the OS, or even the recipes you have in the machine need to be updated on a regular basis. So by combining this into a hypervisor, one part can stay stable and will also boot up always the same after restarting, and the other part can be improved over time to increase security and usability. So this is one part where we can really increase speed of a machine by using a software-defined automation attempt. The other one is my next part, that's within semiconductor fabs. So we also have extremely complex processes here. So those guys are used to have really complex controllers and at the same time using PCs for user interface events. But here we have some other parts. So again, like in CNC, we have this really fast time Ethernet network, because to achieve the precision, those nanometer accuracy and the high throughput, we need to have a really fast and accurate network. On the other side, semiconductor industry has some specific requirements. Just think about bringing a device into the clean room. This costs a lot of money. On the other side, the machines are built for long service times. So you need to have a maintenance ready. So if a computer breaks down, you need to have one already there, especially in the clean room, to have no dropout time. On the other side, they even also can save maintenance service, because if they have a hypervisor and all the images already on the computer, they only need to define which image of the operating system of the application is started. So there's no installation needed. It's really just the mechanical plug and play of the computer. So this really helps them to keep availability at the maximum level, but keep the flexibility as high as they need. And this is honestly, in my thinking, only possible when you have everything software defined, because then you can unplug a software element and put it back in where you need it. And then I have a third use case, and that's regarding medical applications. If you think about modern X-ray systems, which are robotized, so you have the X-ray head attached to a robot, and you're more like lying on a bed, which is also robotized, so that they can move the X-ray head exactly to the position where they want to take a picture. So this is a lot of drives that need to be controlled really safely. And on the other side, the person that is controlling this unit, he's not an engineer, it's a doctor. So the user interface needs to provide an easy to use access. They want simply to move the robot to the perfect position. And on the other side, they need to have the data, which is usually the generated pictures, for example, of your bones or whatever, in 3D. So the user interface here is critical, that it needs to be like user-friendly, and everybody should know how it works. So this is why they use Windows for that. Also good for graphical generation. It's much easier, and the maintenance is, enables higher security, because the safe part is completely like we have several layers of security. It's the OS implementation. It's the firewall built into the hypervisor, and another firewall built into the Windows, as well as separate firewalls, to really make sure that nobody can modify any of those safety relevant data. And it also includes the failback safe state in case of any errors. Again, the process data can be saved in non-volatile memory, while everything else can simply be rebooted. So there's always the key that patient is safe, but maximum flexibility and user friendliness for the doctor.
Thanks, Thomas. It's clear that hypervisor is the powerful engine under the hood. But for machine builders, the other important parts of the solutions would be the applications. We want to see how this workload consolidation actually works on a real factory floor. How do we mix control, HMI, and even AI within one system? Jacob, from the perspective of Control X OS, what does this look like in a real machine? And what functions are your customers combining today?
Excellent question. Thank you very much, Jae-Hong. Let me quickly jump into that, because it's a wonderful opportunity to showcase how our customers use exactly this platform-based approach and that they can select the applications that they actually want to have. And for that, I'm just going to briefly show you the architecture that we have for Control X OS, so that you can understand how this layer works. I already said that, okay, it should be a platform-based approach, and the idea that I have an operating system which is taking care of the real-time aspect, right? So that determinism is a given, so to say, and that it should be secure, and it should be able to run on the devices underneath. So here, for example, I have devices from the Advantech family, but you can imagine also using, for example, our hardware or other partners' hardware. So on the top here, you can see our applications from our store, but on the bottom hand, you can also see, or on the right-hand side, you can also see applications that you can create, so to say. So this is the software architecture where you have modular applications. Now, using that in practice, I brought you a standard customer example for relay inspection. So the idea that in your factory, you want to do quality inspection, and therefore you need to have different hardware setups, but also software setups. And you can there also see the partners. And the software part is always hard to illustrate. Here you have a Control X Core, which is running Control X OS, but it could also be Advantech hardware, for example, running the operating system. And on top of that, you can then install applications. And depending on what kind of applications you install, this device transforms into a solution set. So it's a real practical example of what you can do with it. And you can imagine, depending on which area you have customers with different requirements, and then you can choose the application and just replace them whenever you need it be. And a customer can create their own applications, which is also very critical to understand that there's very specific knowledge, especially manufacturing, which you want to encapsulate as a customer in your app, and then deploy said app on an operating system like Control-X/OS so that you can have your application on it.
Thank you, Jacob. It was such an amazing application story that you shared. It's great
Thank you
to
very
see.
much.
It's great to see how workload consolidation is making machines much more flexible. But there is one more big question that every engineer will ask. What about the safety topic? Traditionally, safety topic was always an isolated island. It had to be separated hardware with very strict regulations. The virtualization or the software-defined topic is always far from this topic. But as we move to a software-defined world, things are getting different right now. So Thomas, can safety functions really share a platform with non-safety tasks? Please walk us through this innovative field of modern functional safety solutions.
The question on this is pure yes. As already discussed or showed, that there is a game changer with the coded processing, and therefore the possibility to have hardware independent safety functionality. And with this approach, it's totally possible to have application with safety content, for example, like the new code is this virtual safe control application, directly beside non-safety application. And with this, you can achieve architectures like shown from Jakob, and which is shown here, where you can combine non-safe application directly beside safe application, and containerization and other technologies for data exchange enables architectures like this and encapsulated the application. And with these kind of architectures, you have all the advantages which comes by SDA. You have a consolidated deployment process where you can handle application directly and encapsulate it. You have the security focus when encapsulating the application. You have a secure data exchange between application by using well-defined APIs, and you have the main focus here, and this is really a game changer for everyone who is aware about safety. You have hardware independent software handling, and this includes as well as functional safety.
Thank you, Thomas. It is impressive to see that safety is no longer a separate black box, but a flexible software capability right now. With coded processing that you mentioned, we can understand the safety can be a flexible element in the era of software-defined automation. Now, we have the real-time engine, the operating system, and the safety software, right? But to make this work, you need a strong and reliable foundation. And that is where Advantech comes in. So first, I want to make a very basic example on how workload consolidation looks like from the perspective of hardware. So here on the screen, you will see one of the Advantech's IPC, or we just call it a random software PLC controller here. So the biggest difference from this software PLC to the traditional PLC that we mentioned is that it's actually an IT-based or a PC-based solution behind. So that means this PC or this controller PLC will have no difficulties at all when it comes to the cloud connectivity to the third-party cloud service or all that kind of IT infrastructure, because it's born in the digital world. Right now, on the era of software-defined automations, with proper software like Docker, like real-time hypervisor, or like a Control-X/OS, then we can turn this PLC into multiple different functions. So with all these different kind of modules, we make the PLC not only PLC right now, but an intelligent platform that we already described in the previous sessions. The current PLC or the current random IPC you just saw right now is actually turned into 3 different kind of devices that you will often see in a factory. First, it can be a test and measurement equipment. Second, it can still be a PLC to do the automation and real-time control. Last but not least, the I/O system and the sensor connectivity is also integrated seamlessly. So in that case, PLC right now, thanks to software-defined automation and all this open infrastructure, we can expect more and more possibilities on the traditional or on the software PLC itself. And as a hardware vendor, we also want to say this is a very huge paradigm shift for these industries. It's great to see how we can consolidate everything into one box now. It's far beyond what we have done in the past 5 decades in the factories.